Hello there! How does an orbital strike work? Before we dive in all of the science, let's have a quick look at what happens during a Planetside 2 orbital strike. When an OS is called in, a giant vertical laser appears, seemingly shot from space. Before any real damage is done, there is a charge-up time of a few seconds, during which your screen gets all glitchy. After that charge-up, the bulk of the energy comes in, causing a massive explosion, a big flash and causing all electronic devices to fry. So, how would such a weapon work? I think we need to look at three aspects: where the weapon is located, how does it aim, and how can it cause so much damage just using a laser. First, the localization. In the game, when you call an orbital strike, that giant laser appears only seconds after the request. This gives an important information. No matter when you call for a strike, the weapon is already above your head, ready to fire. This tells us that the weapon is not carried by an aircraft, for instance, since the aircraft would need some time to lift off and get into position. Instead, I would argue that the weapon is carried by a satellite orbiting the planet. I also think the satellite is sitting at a very specific orbit. Indeed, it is probably sitting in geostationary orbit. But what is geostationary orbit? First, let's explain what it means for an object to be in orbit. Imagine you are trying to throw a ball over a very long table. If you don't put enough horizontal speed into the ball will fall before reaching the end of the table. But if you do input enough horizontal speed, the ball will miss the table by going over it. Putting an object in orbit is the same thing, but the table is instead the entire planet. An object that orbits the Earth is moving at very high speeds. So even though it's falling to the Earth, its huge horizontal speed is causing it to continuously miss the Earth. Yeah, I know, it's a bit weird to wrap your head around that at first. This fact is actually why astronauts on the ISS are experiencing weightlessness. While they are subjected to about as much gravity as you and I, they are in constant freefall. But the horizontal speed of the ISS causes the ISS to continuously miss the Earth during its fall. The station's freefall is what creates microgravity inside it. But here is the thing with objects in orbit. The farther they are from the planet, the longer it takes for them to do a full revolution. And there exists a distance at which an orbiting object does a full revolution in exactly as much time as it takes for Earth to itself do a full revolution. If you put a satellite there, that satellite will always be facing the same side of Earth. And this is why we call this orbit geostationary orbit. This is where I believe you should put your giant space laser. That way, whenever you call for it, you know it's already in position above your head. However, because the orbital strike uses a laser, there is a downside to being in geostationary orbit. Indeed, the intensity of light falls off with the square of the distance. This means that if you multiply the distance by 2, the intensity gets divided by 2 squared, so 4. Being in geostationary orbit means you are quite far away from the ground, whereas being in low Earth orbit means you will get much more efficiency out of your laser strikes. But if you put your orbital strike in low Earth orbit, then you will need a fleet of satellites to ensure that there is always one above your head ready to be used. Now the question of how does it aim? While the satellite can constantly remain above a certain region of our axis, they still need to orient themselves a little bit in order to strike precisely where you want it to. And there are ways to orient a satellite. You can use small thrusters for instance, but the problem with that is that you need propellant and eventually you will run out of propellant, rendering your thrusters useless. So instead, satellites use what we call reaction wheels to orient themselves. A reaction wheel is simply a flywheel installed inside the spacecraft, and it works by taking advantage of what we call conservation of angular momentum. It is something you have probably heard about already. Very basically, it states that the amount of spin in a system remains constant unless acted upon by an external action. Here is a famous demonstration of this principle. Someone is sitting in a chair holding a spinning weighted wheel. Notice that its quote-unquote horizontal spin is 0, because, well, it's not spinning. By putting the rotating wheel parallel to the ground, now the system has a certain amount of horizontal spin. But because angular momentum has to remain constant, then the chair starts spinning in the other direction to compensate for the spin of the wheel. This is exactly what a reaction wheel in a spacecraft does. It starts spinning in a direction, causing the entire spacecraft to spin in the other direction. By turning the wheel by just the right amount, you can precisely orient the spacecraft. There are certain downsides to reaction wheels, like saturation, which I won't get into now, but it is a fascinating topic and I encourage you to look up stuff about it. So that's probably what an orbital strike satellite is using to aim. After all, if it's good enough for the Hubble Space Telescope, it's certainly good enough for a space laser. So, now we know that orbital strike satellites are sitting in geostationary orbit and they are aiming thanks to reaction wheels. That leaves only one question. How do they manage to cause that much destruction with just a laser? First, let's underline that an orbital strike causes an explosion, even though no explosives or projectiles are being used. I see one way for this to be possible. When you heat up a gas, that gas expands. If you heat it up quickly, then it's going to expand quickly. I think this is what the orbital strike is doing. It's hitting the ground, heating up soil and concrete very quickly, vaporizing it and causing such a massive buildup of pressure that you end up with an explosion. Sounds extreme? Well, yeah, that's because it is. But what if I told you that this technology already exists? Well, at a small scale, but still. The US Navy has done some research on lasers as a way to take down targets. The laser is used to heat up the target, causing damage to it. But that's not it. I don't think that's how an orbital strike works. Not quite. Instead, I would argue that an orbital strike is based on a variant of that US military laser called an ultrashort pulse laser system. Instead of using a continuous laser to heat up the target, the system sends very short but powerful laser pulses in quick succession. This would cause an ablation of the top layer of soil, vaporizing it and potentially causing an explosion. Moreover, ultrashort laser pulses tend to create electromagnetic pulses that damage electronic equipment. I think this fits the bill very well. Interestingly, these short pulse lasers aren't that powerful. While their peak power goes in the thousands of billions of watts, the pulses are so incredibly short that their average operating power is in the dozens of watts only, according to the source I found at least, links in the description. Indeed, the laser pulses last a few hundred femtoseconds, and a femtosecond is just 1/4,000,000th of a second. There's one thing missing though. Ultra-short laser pulses can ionize the air, which is what we see in the game because the laser's path glows very bright. This has a very interesting consequence. It means that you can direct electricity through the beam, meaning that if you were to use an orbital strike during a thunderstorm, you would see lightning bolts strike inside the beam. How cool is that? If weather gets implemented in Planetside at some point, I want this to be a thing. So, to summarize, how does an orbital strike work? Well, I would argue that it is a satellite sitting in geostationary orbit, aiming with reaction wheels, and firing ultra-short laser pulses to vaporize the ground, causing a massive pressure buildup, therefore causing an explosion. What do you think? Let me know in the comments. In any case, if you enjoyed the video, feel free to subscribe. You can also come over to my Twitch channel, where I stream Planetside and some other games. You can come by to talk about science and engineering if you want. Thank you very much for watching.